Every 60 seconds, over 400,000 new unique pieces of malware are created and released onto the internet. That's not per day or per hour, that's per minute. In the time it takes you to decide what to watch online, an army of malicious code has been born, designed to steal, disrupt, and destroy. For decades, our defense has been like a bouncer at a nightclub.
What's the password?
This bouncer has a long list of known troublemakers. If someone on the list tries to get in, they are blocked. Simple.
It's as simple as that.
This is your traditional antivirus or firewall. It works on signatures, a list of known threats. But what happens when the troublemaker is new? When they have a fake ID, a new disguise, and an attack no one has ever seen before?
We've been hacked.
The bouncer, relying on his own list, is completely blind. The threat walks right in. This is the reality of modern cybersecurity. The attackers are moving too fast, creating too many new threats, and our digital bouncers can't keep up. They are drowning in a sea of alerts, most of which are false alarms.
9 times out of 10, it's a false alarm.
It's not a question of if a new threat will get through, but when. But what if your security guard could not just check a list, but could actually predict trouble before it starts? What if it could recognize the subtle signs of a person about to cause a problem, just by the way they walk or the way they look around? That's where we're going, and it's powered by a different kind of thinking machine. The greatest weakness of the old security model is that it needs to be told what to look for. And artificial intelligence doesn't. Its first and most important job is simply to watch and learn what's normal. Think about your own daily routine. You wake up, maybe check your phone, commute to work the same way, log into your computer around the same time, access the same set of files, and log out in the evening. You have a rhythm. Your entire company's network has a rhythm. The servers have a rhythm. The flow of data has a rhythm. An AI security app silently observes this for days or even weeks. It's not looking for bad guys yet, it's just learning the baseline. It learns that your finance department usually accesses the accounting server between 9 a.m. and 5 p.m., but almost never touches the software development code. It learns that your CEO logs in from New York, but never from Eastern Europe. It learns that a certain process on a server should only use about 5% of the CPU. This is called anomaly detection. And this is where the magic starts. Because the moment something breaks that rhythm, the moment a user from the finance team tries to access the source code at 3 a.m., or the CEO's account suddenly logs in from a strange country, or that server process spikes to 90% CPU usage, the AI knows. It doesn't need a signature. It doesn't need to have seen this exact attack before. All it knows is, this is not normal. It's a deviation from the baseline, a break in the rhythm. It's the first whisper of a potential threat. But for an AI to learn this rhythm, it needs to be an obsessive listener, constantly taking in information from every conceivable source. So where does it get all this data? An AI is only as smart as the data it's fed. A security AI is like a master spy chief, and it needs a global network of informants. This is the data ingestion layer, and it is vast. First, it taps into the network itself. It sees every packet of data that flows in and out, the digital mail. It reads the logs from firewalls, which are the gatekeepers of the network. Next, it needs eyes and ears on the ground. This means collecting data from every single endpoint, every laptop, server, and phone. It watches which programs are running, what files are being opened, and who is logging in and out. This is like having a security camera inside every room of the building. Then it looks to the cloud. As more companies use services like Amazon Web Services or Microsoft Azure, the AI needs to plug into their logs too. It's watching who is spinning up new servers, who's accessing storage buckets, and what data is moving around in these massive virtual data centers. Finally, and this is crucial, it plugs into global threat intelligence feeds. These are constantly updated lists of a hacker's favorite tools: malicious IP addresses, known phishing domains, and signatures of malware discovered by other researchers just minutes ago. This gives the AI outside context. All of this raw information, billions of events per day, is collected, sorted, and standardized into a single massive stream. We've built this colossal listening machine that's drinking from a fire hose of data. But data is just noise without a brain to make sense of it all. So what does the AI's brain actually look like? The brain of the security AI isn't one single thing. It's a team of specialized experts, each with a different job. These are the machine learning models. First, you have the sorter. This is a classification model. Its job is to look at something and put it into a bucket. Is this email legitimate or is it a phishing attempt? Is this file a harmless document or is it malware? It's trained on millions of examples of both good and bad, and it gets incredibly accurate at telling them apart in milliseconds. Next, you have the watcher. This is the anomaly detection model we talked about. It's the expert that knows the network's rhythm and is purely focused on spotting anything that breaks the pattern. It's the most important defense against brand new, never-before-seen attacks. Then you have the detective.
Hello, detective.
This is a clustering model. A human analyst can get overwhelmed by thousands of small, low-level alerts. They look like noise.
This is way too much.
But the detective's job is to group similar, strange events together. It might notice that 50 different employees all received the weird email from the same sender, or that a series of small probing attacks are all coming from a group of IP addresses in the same small town. It finds the conspiracy in the chaos, turning 100 meaningless alerts into one single high-priority incident. These models work together, passing information back and forth. The sorter might flag a suspicious file, and the watcher might notice it came from an unusual network connection. But spotting individual clues isn't enough. The real magic happens when the AI starts to connect these clues together, weaving a story out of seemingly random events. A sophisticated cyber attack is rarely a single event. It's a chain of small, quiet steps. This is often called the kill chain. A human might see each step in isolation and dismiss it. But the AI, with its perfect memory and total view of the network, sees the whole story unfolding in real time. Imagine this sequence. Step 1. At 2:15 a.m., a user account belonging to an employee named Sarah logs in. The AI's watcher model flags this. Alert 1. Unusual login time. A human might see this and think, maybe Sarah's working late. Step 2. A minute later, Sarah's account, which is in marketing, starts trying to access the company's core software development servers. Alert 2. Anomalous file access. Again, a human might think, that's weird.
That's weird, guys.
But maybe she has a new project. Step 3. The AI sends the IP address Sarah is using to the threat intelligence module. It comes back with a match. This IP address was associated with a known hacking group just last week. Alert 3. Malicious IP detected. Step 4. Finally, the AI sees a large amount of encrypted data flowing from the development server out to this suspicious IP address. Alert 4. Potential data exfiltration. A human analyst juggling dozens of other alerts could easily miss the connection between these 4 separate events. But the AI's correlation engine connects the dots instantly. It sees it's not Sarah working late. It's a compromised account being used to steal company secrets. The confidence level shoots from 5% on the first alert to 99% on the final one. Once the AI has raised the alarm with this level of certainty, it can't just sit there and wait for a human to read a report. The attack is happening now. This is where the system shifts from defense to a powerful counter-attack. The final piece of the puzzle is the response. In the old world, when a critical incident was confirmed, a frantic chain of phone calls and emails would begin. Can someone log this IP at the firewall? Can IT go and unplug that machine? This process could take minutes or even hours. In that time, the damage is done. An AI-driven system doesn't wait. This is the Security Orchestration, Automation and Response, or SOAR layer. Based on predefined playbooks, the AI takes immediate automated action. It can command the firewall, block the malicious IP address instantly. It can command the endpoint security software, isolate the infected laptop from the network automatically. This stops the malware from spreading. It can command the identity system, lock the compromised user account immediately. This cuts off the hacker's access. All of this can happen in less than a second after the threat is confirmed. It's a precise, lightning-fast counterattack that neutralizes the threat before a human analyst has even finished reading the alert. It also automatically creates a detailed incident report, complete with all the evidence, and sends it to the security team for follow-up. This all sounds incredibly powerful, almost like a perfect, unbeatable system. But in the real world, there are no silver bullets. The very same intelligence that makes these AI systems so powerful also opens them up to a new, more sinister kind of attack. Hackers are smart. They know we're starting to use AI, so they've started developing ways to fool it. This is the world of adversarial AI. They might try to poison the data the AI is learning from, slowly teaching it that malicious activity is actually normal. Or they can craft special malware that is designed to look benign, specifically to an AI's analytical models. Like a thief learning a guard's exact patrol route to find the perfect moment to sneak by. This is why the goal is not, and should never be, to completely replace humans. The AI is an unbelievably powerful tool, but it's still a tool. Many complex AI models are black boxes. They can tell you what they think, but not why. That's where the human expert comes in. The future of cybersecurity is a human-machine partnership. The AI is the tireless sentinel, sifting through billions of events, finding the needle in the haystack, and executing instantaneous counterattacks. It handles the speed and the scale that humans can't. The human analyst is the strategist. They take the AI's findings, use their intuition and experience to conduct the deep investigations, hunt for the most subtle threats the AI might have missed, and ultimately make the final judgment calls. They direct the tool, tune it, and keep it honest. So we've gone from a simple bouncer with a list to a silent watcher that learns the very rhythm of our digital world. We've seen how it can build a vast intelligence network, use a team of digital experts to analyze it, and weave together the story of an attack from scattered clues. It's not a perfect system, and the fight against those who want to do us harm is a constantly evolving arms race. But by pairing the immense power and speed of artificial intelligence with the irreplaceable intuition of human experts, we fundamentally changed the game. We're moving away from a world where we're always one step behind, constantly cleaning up the mess. We are building a new reality, one where we have a proactive, predictive, and silent digital guardian watching over us and ready to act before the real damage is ever done. If you found this look into the future of cybersecurity interesting, consider subscribing for more deep dives into the technology that's shaping our world. Thanks for watching.